Good morning, everyone. Welcome back for those of you that have been with us before, anybody that's new. We have kind of a broad audience. There's a lot of people that are now tuning in overseas. Thank you for being here. Welcome to now episode 19. We're going to be going over ceramic membranes with Peter Cartwright. Peter and I go way back. I think we met a good 7 or 8 years ago. While I was doing my master's, actually, Peter was one of the instructors going over the Master Water Specialist program, so that was great. Peter is an engineer. He's been in the water treatment industry now for, I want to say, over 30 years, Peter, or is it closer to 40 now?
It's over 40, it's 46 years.
46 years, there we go. So it's over 46 years in the water treatment industry. One of the courses or specialties that we had to take way back when was on membranes. So we basically took a good, I don't want to say it was a whole semester, but a good half a semester on membranes. So when we were covering ceramic membranes, the first person I thought of was, well, why not get Peter on? So it's an honor. Thank you, Peter, for being here. For those of you that haven't been with us before, I reckon everybody can see my screen. These are some of the webinars that we've covered. So now we're up to 19. We were going to be doing trihalomethanes this week, but due to some scheduling conflicts, we changed it around. And thank you, Peter, for covering this. All of this is now available on our YouTube channel. So if you need to go back and take a look at them, please, they're all there. I can provide a link through there. So for those of you that are new to AWC, we have been around for over 40 years now. We design and manufacture water and wastewater treatment plants. We have close to 600 plants worldwide in operation. We are now working on projects in Latin America and in Africa. We design them and we kind of divvy them up into 3 categories. We have everything that has to do with potable water, wastewater, and skid-mounted systems. When we take a look at ceramic membranes, which we'll be going over in a bit, we focus more on the skid-mounted system. However, because of the modular fashion of some of these, you can actually tee them up and you can put them together. So if you were going to start with something like a adaptive dissolved air flotation, you can always partner it up with a membrane. And the same thing would apply if you're going for a tube settler for high turbidity. You know, sometimes we can deal in 1,000 or 2,000 NTUs. You could potentially follow it up with a membrane system. So with that, Peter, we're going to switch it over to ceramic membranes.
All right. Sorry about that, but I've been in the membrane industry for a long time, and I've really never dipped a toe into the digital field, unfortunately. I have granddaughters that tell me what to do, or in this case, Alex. But at any rate, I want to talk a little bit about ceramic membranes. These are basically categories of membranes that are non-polymeric, and I'll get into those in distinguish the differences in a moment. But basically, I presume everybody that is tuned in here is familiar with membrane technologies, and they basically are called cross-flow, pressure-driven membrane separation technologies. And there are 4 of them in use today that use pressure as the driving force to effect separation. In the case of ceramics, they are the newest player on the block, although some have been around for many, many years. But generally, the membranes have, when they were initially constructed, they were polymeric. And when we talk about ceramic membranes, we have to put them in the right category. There are 4 different categories of membrane separation technologies: microfiltration, ultrafiltration, nanofiltration, and reverse osmosis, or what used to be called in Europe hyperfiltration. At any rate, historically, microfiltration and ultrafiltration were developed, particularly in Europe, many, many years ago. Reverse osmosis and nanofiltration really came out of the US in the mid to late 50s. So the genesis of these types of membranes are quite different. But with ceramic membranes, they have basically, the ones that are available today are available in a number of configurations, and we'll go into those in a minute. But as I mentioned, they're non-polymeric, and most of them are based on aluminum oxide, although some are made out of titanium, titanium oxide, and zirconium oxide. And there are some in the past that were made out of carbon layers. Next slide, please. So when we look at these devices, it's one thing to have a material that will reject certain contaminants, but another thing to be able to put it into some sort of a configuration. And so the devices or the configurations that are available in the industry today, you will notice from the left-hand side, the materials of construction are primarily polymeric, and these are all of the different polymers, and there are new ones coming on the market all the time. So it's not complete. The non-polymeric, or other words, what we typically call ceramic membranes, also include stainless steel. Obviously, that's not ceramic, but that's one of the categories. Alpha alumina, the aluminum oxide, titanium dioxide, silicon dioxide. But the configurations that these are available in are more limited than the polymeric. You'll notice that, at least as of this point in time, there are virtually no true hollow fiber configurations made from ceramic membranes. Tubular, yes, and some of these tubular devices are very small in diameter, but they're still tubular as opposed to hollow fiber. Plate and frame, quite limited, and spiral, no. Now, this chart is always, this was created some years ago, and there may be exceptions to it now. There are new developments coming in the membrane field every day. But at least at the time that I put this together, these were the latest data. Next, please. Now, with regard to nanofiltration and reverse osmosis, you will notice here the polymeric membranes, the polymeric choices are very limited, and there are virtually no ceramic membranes that are true MF or NF or RO construction. In other words, I define nanofiltration and reverse osmosis technologies as the rejection of salts, any ionic component. The RO and NF membranes are capable of rejecting ions. MF and UF do not reject it. So based on that definition, there are no ceramic membranes that are capable of rejection. Next, please. These are just some illustrations. There are many, many different constructions, many different configurations within the constructions. Plate and frame, tubular, hollow fiber, and as I said, the are only available in RO and NF configurations. But these are just some illustrations. Next, please. Here's some more. These list some of the manufacturers, and some of these manufacturers may be out of business. There are always new ones coming out, but you'll notice there are significant choices. And most of the ceramic membranes on the market today are aluminum oxide. Next, please. You can get large diameter tubular. You can get these various configurations. Everyone has characteristics that may be advantageous in different applications. Basically, the primary advantage of the ceramic material versus polymeric is high temperature. The ceramics can go up to much over boiling temperatures. They can be up in the high 3-digit numbers for temperatures, and also they're pH tolerant, particularly low pH. They can handle very, very strong acidic solutions, for example, and still retain their properties. Next, please. These are some more configurations. You'll notice they're not just square cross-section or circular. There's even a star-shaped device that was made in England at one time. I'm not sure if it's still on the market. Some of these slides are quite old. Next. And they can be put together in any number of designs. On the lower left is our devices that have a stainless steel housing, so they can be operated under high pressures if necessary. And on the lower right is actually an installation of ceramic membranes that are could be using. They could be in a food application for fractionating cheese whey, for example. Excuse me. Next, please. This is kind of an extreme. This happens to be a zirconium oxide coated stainless steel. It's made out of tubular devices, and it's primarily used for, in this case, for separating catalyst from a solution, a reaction solution at very high temperatures. And one of the characteristics of ceramic membranes initially was their cost, but they have come down very competitively, and now in some cases can even compete with polymeric membranes. But as I said, traditionally the advantages of the ceramic membranes is their pH tolerance as well as high temperature capabilities. Next, please. This is a chart or a list of manufacturers, and it's quite old, so I'm not gonna stand behind it as far as its accuracy goes, but it just gives you an idea of some of the manufacturers, the membrane materials they use, the maximum pore size, and the configurations. The multi-channel is basically a type of tubular, and I will comment that under configuration I have listed hollow fiber when it really indicates small diameter tubular membranes. They're not truly hollow fibers, which are by definition flexible. And it gives you some idea of the pH range of these. And as I said, I can't guarantee the accuracy of this, but it does give you a pretty good cross-section of the manufacturers and of the materials they use. And you'll notice that most of them use aluminum oxide, although there are a couple that use silicon carbide, which has been coming on the market with a certain degree of capabilities. But this just gives you a feeling for the numbers of manufacturers and the offerings that they have. Next, please. So I guess I ended on time, Alex. So do you want to open it to questions or what?
Of course. Well, we pretty much covered everything that had to do more than membrane configurations, but more on the ceramic membrane composition and some of, I guess, limitations as well. We can go ahead and open it up to questions. Don't be shy. Go ahead and turn on your camera and you can ask live, or you can put it in the chat box. I do have a couple questions myself, so maybe I can start and anybody can put their questions in there. You had mentioned that on the ceramic membranes, they don't include any hollow fiber ceramic membranes. Is that because of their delicate composition, or is there manufacturing restrictions or limitations on how to make them?
Well, yes to all of the above, Alex. But I guess, like any other industry, we have our own terminology and suite of definitions. And keep in mind that the original hollow fibers were made out of polymers, unsupported. The other configurations with polymeric membranes have a backing material. Spiral, tubular, frame are all involve coating a polymer onto typically a non-woven backing material. The hollow fiber, by definition, has no backing material. It's the solid polymer itself. Now, given that these are extremely small diameter, we're talking about millimeter or fraction of a millimeter, you can extend that definition to include ceramics to that I am not aware of a ceramic with enough strength to support itself in a let's say sub-millimeter construction. It's still the hollow fiber is still a tube, but it's a tube without any support. And I think you need the wall thickness that's inherent in the small tubular ceramic membranes that you don't get in the hollow fiber. Now, other people may argue with me and they say, well, this is a hollow fiber because it's a small diameter. Well, regardless, it's still in a larger diameter, it would be a tubular ceramic. So, it's a matter of terms. But
yeah, the definition, I guess, would fall under what exactly would be considered. So I do have another question here that says, what is the best method to clean them?
Well, that depends on what you're trying to clean them from. If it's for example, a ceramic membrane bioreactor application, typically they use chlorine, sodium hypochlorite solutions to clean them. But the typical cleaning solutions that you encounter are acid, caustic, enzymatic, these sorts of cleaners. And one advantage of the ceramics is they will take just about any material. As you are probably aware, the aluminum oxide are a little sensitive with high pH solutions, high caustic solutions. But in general, the ceramic membranes will take almost any cleaning solution that's thrown at them. So they're much more versatile in that regard.
Okay, so we have another question here so other than cost, so cost aside, why are ceramic membranes not used more widely? And what causes non-recoverable fouling of ceramic membranes? I guess that's two questions there.
Well, the first question is that number one, history is against the manufacturers, and they're working hard to overcome this. History meaning cost. Another downside is they're much more fragile. You don't drop a ceramic membrane. You can drop a spiral wound within reason, but so a downside of ceramics has historically been fragility. On the other hand, obviously if it's stainless steel, if you want to include that as a ceramic, you don't have a problem with fragility. But anyway, that's that, and the cost has primarily been the disadvantage. And one more comment about the hollow fiber. Keep in mind that the polymeric hollow fibers, you can literally roll them up, and they're very, very flexible. And obviously, that's a limitation with any of the ceramics. And that's also, I didn't really mention it, but that's one of the reasons why you don't see ceramic spiral wound membranes. Just they would be too hard to manufacture for any advantages they may offer.
And then the second portion of the question was, what would cause a non-recoverable fouling of a ceramic membrane?
Well, I can see in a wastewater application where you might get literally an attack of the aluminum oxide or the ceramic material itself. So there might be a chemical issue, but probably more likely is because that occurs with membranes too, is when the foulant gets down inside the pore itself, where it starts to penetrate the pore. It just becomes a mechanical issue of how do you get rid of this without damaging the pore. So that's the sort of irreversible fouling. And of course, as everybody knows, that is the Achilles heel of all membrane systems, regardless of the materials.
Okay, I have a question here from Jim from Ohio. So, are all ceramics membranes configured with an inside-out flow arrangement?
No, not necessarily. Most of them are, and most of the ones you saw in the illustration. But you can certainly, just like you can with the polymeric hollow fiber or tubular membranes, you can go outside in, and each one has its advantages and disadvantages. But I would say the vast majority of hollow fiber, of ceramic membrane installations are inside out, but they don't necessarily have to be.
Okay, and another question here was, what applications have you applied ceramic membranes?
Well, I had one application that involved, and I don't remember for sure what the application was, but it was, I believe it was an ethanol recovery plant or an ethanol manufacturing facility where they had to separate the waste material from the liquid stream, and it was mainly particulate removal, but it was all done at 180 degrees Fahrenheit. So this really precluded polymeric membranes, and it was just about perfect for ceramic. They are excellent in high temperature applications. And the advantage was, of course, they didn't have to cool down the stream, and they didn't encounter the thickening, the increase in viscosity at lower temperature. So this was tailor-made for ceramic applications.
So, since you mentioned temperature, and we're getting pretty close to the time here, we're at 23 minutes. My question was, you mentioned that these have a very high heat tolerance. So you can go up to, in the hundreds, maybe potentially up to 200 degrees. Would you ever backwash or do your, traditional CIP with hotter water? Like if you're operating at 70, 80 degrees, would you potentially do your CIP at 180 degrees?
Absolutely. As everybody in the polymeric business is aware, the warmer the CIP solution, the more effective it is at cleaning. So there is another example where the high temperature tolerance of ceramic membranes would actually help in cleaning.
Excellent. Well, I want to thank you so much for your time, Peter. I know you're pretty busy on your end. You've got a couple more courses that you're going to be working on. Oh, here we go. One last question. We'll make time because I think this is a very good one. So at higher temperatures, how do the TSS and NTUs or organics behave?
Well, and as you're probably aware, that depends on what they are. But generally, at higher temperatures, um, they are more likely to soften, and those organics that are more inclined to do that, that could be a problem. Um, so fouling minimization and cleaning uh, requirements are so site specific that temperature is a factor, but temperature may come back and bite you too. So uh, if it's just inorganic particles, I, it's not an issue with regard to temperature, in my opinion. But if it's something that may tend to soften when it gets hot, that's a disadvantage. If it's something that will tend to dissolve more readily, like an organic, when it's hot, um, that will allow you to remove it. And a whole other category are the oils and um, uh, that type, whether it's emulsified oils or free oils or whatever. That is a whole nother fouling issue.
Excellent. Well, again, thank you, Peter, so much for your time. Thank you, everybody, for tuning in. Next week, we're going to be doing some of the principles of water chemistry. I was asked, or somebody suggested, that maybe we go back to some of the core of the water chemistry before we got into some of the, trihalmethanes or dioxanes and some of the more complex contaminants. So with that, thank you very much for your time, everybody. Of course, a final plug. All of this is on our YouTube video. We're posting all of these. You're going to get a quick email with a link for a recording for this if you want to review it. If you do have any more questions, of course, Peter's contact information is in there. I thought I had your phone number in there, but for now, we'll just stick to the email. Please make sure that you drop him a line. And with that, thank you very much and see you next week. Goodbye.
Bye-bye.